Hello. So in this lecture, we discuss false position method. In Latin, it's called Regula Falsi method. So false position or false assumption method goes back to the ancient Egyptians or Babylonians. The name comes from the fact that we start by supposing, positing our solution, though we know it is false, and using the information obtained to get a new answer, which for some linear problems will in fact be the exact answer, but for others, nonlinear will just be better approximation. The poor convergence of the bisection method, as well as its poor adaptability to higher dimensions, that is, systems of two or more nonlinear equations, motivate the use of better techniques. This method is improvement over slow convergence of bisection method, particularly for functions that are smooth near a root. False position or regular falsi converges faster than bisection method, an iterative method for finding a root of the nonlinear equation. It employs the same formula as the secant method but retains at each stage the two most recent estimates that bracket the root in order to guarantee convergence. So what is in this, the first paragraph, we have seen that the false position method can also be called as false assumption method, and in Latin language we called it Regula Falsi method. This is the most old method which is being used by the time of Egyptians and Babylonians. Why we called it false position? The name comes from the fact that we start by supposing a solution we know it is false. So this method is based on trial and error. So we suppose that this is the solution, but we see that actually this is not the solution, but this is an error. So that's why it's called false position method. And using the information obtained to get a new answer, which for some linear problems. So for the nonlinear equation, we try to make it linear and guess the initial approximation. But for others, nonlinear will just be a better approximation. So we know that sometimes the initial guess is an exact solution of the linear part of the equation, but it is just can be considered as the better approximation of the nonlinear equations. So why this false position method is needed to be invented or to constructed? Actually, the poor convergence of the bisection method, it means the convergence of the bisection method is very slow as its poor adaptability to higher dimension, and maybe it is not convenient or efficient to use it for the higher dimension of equation. Higher dimension mean the system of equation of more than two or higher more than two, or number of equations should be greater than two. Motivate the use of better technique. So in finding a better technique, the scientists and the mathematician have succeeded to develop the false position method actually. So this method is an improvement over slow convergence of bisection method, particularly for functions that are smooth near a root. False position converges faster than bisection. So this is an iterative method for finding a root of the nonlinear equation of the type f of x is equal to 0. It employs actually the same technique as we use in secant method, but it retains at each stage the two most recent estimates that bracket the root in order to guarantee convergence. So actually, bisection method and regular falsi method are examples of the bracketing rule methods. So there are two types of methods. One is the bracketing methods, the other is the open methods. The bisection method and regular falsi method is an example of the bracketing methods. So all the formula can be derived for the regular falsi method. So just consider as suppose we have the curve y is equal to f of x is the red colored curve is actually the curve drawn by drawing the function y is equal to f of x, and just mark 2 points at the curve. One point is f of b, the other is f of a. So f of a is the point corresponding to the point a on the x-axis, and f of b is a point corresponding to the point on x-axis b. So then we extend this line up to b and this to b to c to just make a geometrical proportion to derive the formula. So that is why was the proportion of EC with BC is the same as the proportion of ED with AB. So this will help us to drive the formula. So if you just look at the figure, it is easy to find that EC is equal to X minus A and BC is equal to B minus A. Similarly, ED is corresponding to f of x minus f of a, and AB is corresponding to f of b minus f of a. So then after simplification, we can get the formula x is equal to a plus b minus a minus f of a. And if we denote the first root with p, so then x will be replaced with p. So then we will get the formula of Regula Falsi method. So to remember the formula, just remember the denominator. So denominator is f of b minus f of a, and write the denominator again in the numerator, and then multiply f of b with a and f of a with b. You will get the formula, and this trick will help you to remember the formula. So determine real roots of nonlinear equation using Regula Falsi method. The following steps are necessary to be executed. The first step, if the interval is not given, then we will find the interval on which the function has opposite signs. Why we need to determine this interval? Because we will apply this intermediate value theorem to guess where is the root and in which interval the root lies. The second is to set the degree of accuracy. Uh, so if you are given that find the answer up to correct up to 3 decimal places, then epsilon should be is equal to 0.000, and then after 3 zeros you may have a one digit between 1 to 9. So that is also called tolerance in some programming language like Maple, or degree of accuracy. And then the given interval can be set as a1 is equal to a and b1 is equal to b to compute the first iteration. And in the fourth step, the improved root will be estimated by using the Regula Falsi method. So if I is equal to 1, then it will compute the first iteration. And if I is equal to 2, it will compute the second iteration. If f of p is equal to 0, it means this value of p will satisfy the given function, and this will be considered as the root. Otherwise, we will go to next step. So if the f of a and f of p will have opposite sign, then the product of f of a and f of p will be less than 0, and the root will lies in the interval AP. And if the product of these two values will be less than 0, then the definitely root will lies within the interval P and B. And this is the stopping criteria where you will stop the function or how you will stop this algorithm f of p and absolute value less than epsilon. So if this value is less than epsilon, then so pn will be the root, otherwise we will move to the previous steps. So here is the remark: the false position method uses the property that a straight line joins two values f of xi and f of xu. So we can say that this is the initial value and this is the upper value. So for example, if you have chosen two values in the interval xi and xu, okay, or xl, you can say it's a lower value, and xu, you can say it is an upper value. Okay, so the false position is the property that a straight line joins these two values. The intersection of this line with the x-axis represent an improved estimate of the root. So that is the difference between bisection method and regular falsi method, because in the regular falsi method you join the line with f of xi and f of xu. Okay. So although the false position method is an improvement of the bisection method, in some cases the bisection method will converge faster and yield to better results. So here is the drawback of the false position method, because in some cases bisection method is still faster, but in more than one cases you can say uh, overall this regular falsi method is faster than bisection method, but there exist some cases where the bisection method is faster than regular falsi method. Here is an example. So in the example, the function x cubed plus 4x squared minus 10 at the interval 1, 2. For first iteration, set a1 is equal to 1 and b1 is equal to 2. So it gives f of a1 is equal to minus 5 and f of b1 is equal to 14. So compute the first point as given below. So using the regular falsi method. So we will get the first value 1.26 and then put this value in the function f of x. You will get minus 1.65, which is not equal to 0. It means minus 1.65 is not a root. So we will move to compute the second point, which is in the interval 1.26 and 2. And now we will set the next interval as a2 is equal to 1.26 and b2 is equal to 2. Okay, so then we will compute the value again. A2 f of b2 minus b2 f of a2 over f of b2 minus f of a2 is equal to 1.33. So then we will set this value in the function and compute the new value. So in this way, we continue this process until we will achieve the degree of accuracy as desired. So here the root of P4 is 1.36 and also of P5 is 1.36. So it means we have obtained the answer correct up to 2 decimal places, because after point the 2 decimal places are similar in both roots. So this is the method by which we can compute the roots using regular falsi method. Before ending, we can just repeat. So false position method or false assumption method. What kind of tricks we use in the false position method? That is, if there are two values as initial guess or the interval, so the false position method actually draw a line passing through these two initial values, f of xi and f of xu. So that is the difference. This straight line joins two values, and the intersection, this line with the x-axis actually represents an improved estimate of the root. Okay, so and if we want to derive the formula, we just have to make the comparison of the ratios and we will get the formula. The steps of the formula are similar as we have done with the bisection method, and we will find the interval in a similar way to just evaluate where the function has the negative sign or positive sign. Okay, so we can also point out some drawbacks of bisection method. So some of the advantage of bisection method is that the bisection method is always convergent. Since the method bracket the root, the method is guaranteed to converge. As iteration are conducted, the interval gets solved. So one can guarantee the decrease in the error in the solution of the equation. So that is the advantages of bisection method. And what are the drawbacks? Convergence of bisection method is slow as it is simply based on halving the interval. And if one of the initial guess is closer to the root, it will take larger number of iterations to reach the root. So that is another disadvantage is because your initial guess is even closer to the root, but still the algorithm is taking more iterations. So number three, if a function is such that it just touches the x-axis, for example, the function like this one, it will be unable to find the lower guess or an upper guess such that the product of 2f of a f of b less than 0. For functions where there is a singularity and it reverses sign at the singularity, bisection method may converge on the singularity. For example, if we are given a function f of x is equal to 1 over x and with the interval a is equal to minus 2 equal to 3 are valid initial guesses because at x equal to minus 2 the function has the value and at x equal to 3 function has also value. So if we find the value x is equal to 0, then it should satisfy as a root. But if we put this 0 in this function, it will become as indeterminate form. So that are the disadvantages of the bisection method. So due to these disadvantages of the bisection method, so there is the motivation to drive a new techniques like a false position method. But this false position method is one of the most ancient method that is older methods. So, but still it is in use and it is faster than the bisection method. I can just repeat this in your local language. बाइसेक्शन मेथड में चूंकि प्रॉब्लम्स थी और उसमें ड्रॉबैक्स थे और वो स्लो कन्वर्ज कर रहा है, इस वजह से फॉल्स पोजीशन मेथड की नीड पेश हुई आई इसको इन्वेंट करने के लिए। फॉल्स पोजीशन मेथड जो सबसे पुराना मेथड है और ये मिस्र और बेबीलोनियन के लोगों की वक्त से यूज़ होता है। ठीक है, इसको फॉल्स पोजीशन इसलिए कहते हैं कि हमें पता है कि ये जो आंसर है ये इसका एग्जैक्ट आंसर नहीं है, लेकिन हम हिट एंड ट्रायल रूल से मेंशन करते हैं। इसमें और बाइसेक्शन में ये फ़र्क है कि इसमें जो इनिशियल गेस के करस्पॉन्डिंग वैल्यूज़ हैं एफ ऑफ ए और एफ ऑफ बी, उसके दरमियान एक स्ट्रेट लाइन ड्रा करते हैं और वो लाइन जहाँ पे एक्स एक्सिस को कट करती है तो वो हम उसको इम्प्रूव्ड रूट कंसिडर करते हैं। ठीक है, बाकी में क्या होता है कि हम बाइसेक्शन में टेंजेंट ड्रा करते थे कि वो टेंजेंट लाइन जब एक्स एक्सिस को क्रॉस करती है तो उसको हम इनिशियल, उसको हम इम्प्रूव्ड रूट मानते हैं। जबकि इसमें ये है कि वो जो एक्चुअल लाइन है जो एफ ऑफ ए और एफ ऑफ बी पॉइंट्स को क्रॉस करती है, टच करती है, वो लाइन जहाँ पे एक्सेस क्रॉस करती है उसको हम इम्प्रूव्ड रूट मानते हैं। तो दैट इज द डिफरेंस बिटवीन टू मेथड्स। ठीक है, क्योंकि बाइसेक्शन में पॉइंट के ऊपर हम टेंजेंट ड्रा करते हैं और टेंजेंट लाइन जो है जहाँ एक्स एक्सेस को कट करती है उसको हम रूट कहते हैं। बाइसेक्शन मेथड में दो जो इनिशियल गेस हैं, दो वैल्यूज हैं, ठीक है, एक वैल्यू फिक्स रहेगी और एक चेंज होगी। तो उन वैल्यूज जो एफ ऑफ ए और एफ ऑफ बी कह लो, उसको जो ज्वाइन करती है लाइन, तो वो जहाँ पे एक्स एक्सेस को कट करती है उसको हम रूट कहते हैं। जैसे ये देखो, ये एफ ऑफ बी है और ये एफ ऑफ ए है, तो इन दोनों के एक लाइन ड्रा की है, ठीक है। तो उस लाइन एक्स एक्सेस को कट की है एक्स, ये एक्स वन के ऊपर, इस वजह से हमने एक्स वन को एक रूट माना हुआ है कि ये इम्प्रूव्ड रूट है। अब ये लाइन जैसे जैसे नीचे आएगी, तो ये रेड लाइन जहाँ पे एक्स एक्सेस को कट कर रही है, ये लाइन इसके करीब आएगी, तो फिर हम कहेंगे कि ये रूट डिक्लेयर हो गया है। तो ये डिफरेंस है। अभी बाइसेक्शन मेथड में देखें उसके ग्राफ में, तो उसका ग्राफ कैसे है कि जब ये देखो, ये पॉइंट ड्रा किया, कोई भी पॉइंट, ठीक है, इस पॉइंट पे टेंजेंट ड्रा की है, तो जो टेंजेंट है, ठीक है, उसने जहाँ पर कट की है, ठीक है, यहाँ पे फर्ज करो ये पॉइंट है, तो यहाँ टेंजेंट को टेंजेंट लगाएंगे और जहाँ पर उसको एक्स एक्सिस को क्रॉस करेगा उस पे हम कहेंगे कि ये रूट है। लेकिन भाई रेगुलर फाल्सी में क्या है कि जो दो पॉइंट्स हैं एफ ऑफ ए, उनके दरमियान जो लाइन है वो जहाँ कट करेगी उसको हम रूट कहेंगे। तो ये दोनों में मेन फर्क है, ठीक है। सो इट इज सपोज्ड दैट you have completely understand. If not, then you can write me.